going to continue today with this concept of correlation and coming up with the line of best fit in the equation of a line for a particular set of data. Um, just to go over a couple of things, and then we will go to the calculator to show you how to do all of this. Okay, now um, the line of best fit, as we talked about in the prior lesson, is the line that most closely follows a trend in the data. In the previous lesson, we we came up with the line of best fit kind of by hand, figuring out which line best represented the data point. Today, we're going to do it using the calculator, which is a more exact way to do it. When we come up with this line of best fit and the equation of the line, we can use it for interpolation, which means if we want to find the result for a data value that we don't already have, that's between or inside our domain, or data values and range. And extrapolation is we're trying to find a value that's outside our given domain and range. Now, I'm not going to read through what this says here in terms of the calculator instructions. What I'm going to do is show you how to use the calculator for this particular example. Okay? So what we have is money spent by the government on math research from 85 to 95. Now, you have to understand that you still have to identify that the year is X and the amount is Y, and you're going to see how we use that in a moment. And what I am telling you here is instead of putting in the year 1985, you're going to put in 0. Instead of 1986, 1, 2, 3, 4. Okay? Sometimes you're asked either by myself or on the Regents to, instead of put in the full year, it just makes it a little bit easier to use the smaller numbers. Okay? Now, let's call up the calculator and let's go through how we would do this. Now, I'm going to go over to my computer to do this. Okay? Now, what we want to do is we want to enter our data points into the calculator. So we hit the stat button and we hit enter, or edit, which is what it's already on. And you're going to see we come up with a table, an L1 and an L2. And I actually already have some data in there. So I need to clear that data out. So if you move the cursor up to L2 and L1 and hit clear, enter, it'll clear all the data out for you. It's just a shortcut as opposed to going in there and clearing each one by one. So my L1 is like X. So I'm going to input my 10 years. So 0, enter, 1. Now, what's very important is you have to be accurate when you enter this data. If you make any mistakes with the data values, okay, then you're going to get an incorrect answer. Also, if you have more data in an L1 or L2 than is in the other one, you're going to get an error message from the calculator. Okay, so now you've entered in all the data. And what we want to do is we want to have the calculator give us the equation of the line of best fit for this. So we're going to go back to stat, and we're going to go over to calc. And if you look on line 4 there, you'll see it says Lin regression, AX plus B. Well, that obviously looks very familiar to our line and slope intercept form, and that's exactly what we want the calculator to tell us. So we move the cursor down there, we hit enter, all right? It comes up with that's what you want to do, yes, and we hit enter again. Now, what the calculator has just told us is some very important information. A, the 15.4, and you look here, it has y equals ax plus b. I do not know why they don't say y equals mx plus b, but they use the a and the b. So A is our slope, B is our y-intercept. And then you'll see R squared and R. R is that correlation coefficient that we talked about. And you'll see it's 0.99, which means this data has a strong positive relationship. Okay? So now we're going to go back to our sheet. So what type of correlation is shown by the data? Well, you could see by R being the 0.99 that we said that it's a positive. And you could even see that from looking at the data that as the year goes up, we're trending up all the way. The equation for the line of best fit, y equals 15.4x plus 94.7. And then is the correlation coefficient, is it excellent, good, fair, poor? Now, we're not going to leave this to be too judgmental. It's going to usually be at one extreme or the other. Okay? So this is 0.99, R equals 0.99, and that's an excellent. Okay? If it tracks somewhere like 0.5 or 0.3 or something that's right in the middle of 1 and -1, that's where it gets to be poor. Usually, it's a very clear, not much judgment to what's going on here. Okay? So I'm going to go back now to the next questions. Now, I'm not going to do all of these on the calculator because all you're going to do is sit there and watch me type in information. So I'm just going to give you the answers to the rest of this, and you should be checking that what you did on the calculator matches up. For number 2, this is a negative correlation. The line of best fit is y equals -1.01x plus 88.14, and R is -0.98. Again, what you should notice is if it's a negative correlation, my slope should be negative and R should be a negative. If that's not the case, you're making a mistake somewhere. Okay? Now I want to do a linear regression for the value of cottages. That's a certain number of blocks from the beach. Your equation there, y equals -34,739.71x plus 313,309. Right. Now, if you're located 3 blocks from the beach, then what you would be doing is the block from the beach is x. You would put 3 in for x. It's not leaving it x, right? Putting in 3 and solve. And so you get 209,091. And again, your numbers should be making some sense relative to the data. If you look, 3 blocks should somewhere be between the 2 and the 4 here, and it is. Okay? It's not perfectly in the middle because that's not necessarily how the data trends, but at least it makes some sense. Gasoline and year. Okay? Now, this is telling you to put in the actual year itself. All right? So there you would get -6.2x plus 12,451. You can see and expect that as the years are going up, the gas that's available is going down. 2005, I want to figure out what that's going to be, so I'm going to put 2005 in for x. And I get that to be approximately 20, okay, gallons in thousands. And when will gas become unavailable? Well, if you think about it, what that's asking you is when is the gas Y at 0? So I'm now going to solve for X in this equation, and I get X to be 2008. Okay, so again, the what this lesson really comes down to is you've got to practice how to input the data and get the line of best fit on your calculator. Now, one other thing just to remind you of here, going back to the calculator, if your calculator doesn't call up the R, okay, then that means you haven't put what's called the diagnostics on. All right. And the way you would do that is you hit second 0, and you're going to come up with a catalog. And you're going to scroll down, and there's probably somebody will tell me a quicker way to get there than just doing all of this. But you're going to move your cursor down to the word diagnostics on. Now, my diagnostics are on already, so I don't need to do this, but I'm just showing you because that's another function you need to know how to do on the calculator. Okay, so you go to where it says diagnostics on, your cursor's there, you hit enter, and you hit enter again, and your diagnostics are on. Okay, so that's how you use your calculator to do the line of best fit.